We are going to talk about the area of regular polygons and the formula for area of regular polygons, and that's right here. But before we do that, we need to discuss a few things. A regular polygon just means that all the angles are congruent and all the sides are congruent to each other. Whenever we mention the words center of a polygon, that point is going to be the same distance or equidistant from the vertices. So that's really called like the radius. So it goes from the center out to the vertex of your shape. Next is the apothem, which is kind of an odd word, but that's the little a over here in our formula. And the apothem is the perpendicular distance from the center to the side in the polygon. So that's this dotted line right here. So it's perpendicular straight to the edge. That in a regular polygon, that would be the same on all of the different sides, but that's the number we're going to need for the formula. The central angle of our regular polygon is the angle created by drawing a triangle connecting all of our center to all of the vertices. So those would be congruent triangles. They will all be the same because it's a regular polygon. But how you found that is you take 360 degrees, and we divide it by the number of congruent sides. So in this figure, we take 360 divided by the 5 congruent sides, and that's how we got the 72 degrees in our picture. So depending on what shape it is, if it's a hexagon or a pentagon, or it could be even a triangle, we would take 360 divided by those number of sides. So now for the formula is going to be 1/2 times the apothem length times the perimeter of the full polygon around the outsides. And number one, we're going to start it out pretty simple. And what I suggest that you do on each question is off to the side, before you plug anything into your formula, you list out what is the apothem, what is the length of your perimeter. And that way it'll make it easier when you put it into your formula. So for the apothem, that is the 4.3, so that's our height right there. Then for the perimeter, we see one of the sides is 5, but there are 6 sides that are congruent. That would give us a 30 for the perimeter. So when we fill it in over here on the side, we've got 4.3 for the apothem times 30 times 1/2, and that gives us a total of 64.5 units squared. Now for number 2, we need to find the area of the regular pentagon. So notice there are 5 sides instead, and we need to know how to find the apothem if we only have a side length. So remember, let's list it out. Our perimeter, we know there's 12 for one of the sides times 5 equal sides. That gives us a 72 for the perimeter, but we're missing the apothem, and we need to find that straight up and down. So what we do is we divide our shape. Remember, it's really divided up into 5 equal triangles. So we're going to draw one of our big triangles right here. And we know the side length is 12, so that's down here. And we need to figure out what is that central angle going to be. So we need to take 360 and divide it by 5, and we get this 72. So up here we've got 72 for that central angle. But just like we saw on a previous one, if we go straight down, that's going to cut that angle in half. That means that this angle is only 36 degrees, and this other angle then would be 54 degrees. When we go straight down, that's going to cut this side in half, so both of those are 6. And we need to use sine, cosine, tangent to figure out what this apothem is going to be. So we need to label the sides based on our angle. Let's base it off of, let's say, 54 right here. So this side would be opposite. We have adjacent, and we have our hypotenuse. But notice we've got our adjacent because we have the 6, and we need to find the opposite. So we would use tangent of our angle, which, remember, tangent of an angle is opposite over adjacent. The angle that we are using is the 54. The opposite we labeled as x. The adjacent was 6. Now remember, when we solve this, we cross multiply, which gives us x equals 6 times the tangent of 54, and now we can type this in the calculator. Don't forget that you need to put your calculator into degree mode when you type that into the calculator. When we do this, we end up with 8.258 for our apothem. So that goes up here, so 8.258, because that's the height of this triangle. But remember, in the big pentagon, that is the height of our apothem. And now we can take our 2 values and find the area of our pentagon. So I want you now to tell me what is the area of your pentagon going to be given the different values. So substitute it into the formula and multiply it out and tell me what you get. After you put in the two values, you should have gotten 247.74, and that would be centimeters squared is what your area should end up with. Now number 3 will be something similar, but we start with a different piece. This time when we divide up our triangle, notice there's 6 sides to it, so when we take 360 divided by 6, we get 60. So my central angle up there is 60. So if you draw this big triangle out, we know the central angle is 60. This side is 8, but if you notice, this is the radius of our shape, and if it's regular, those distances should all be the same. So this side will also be 8. That does not mean that this third side will also be 8. What we need to do is use these two then to find what the length of the side is and to find the apothem length. In our triangle, when we divide it up, that would make that these two angles are 30, so down here is the 60. We need to find the apothem. We also need to find one of the lengths over here, so just from those pieces, so that we can double it for the side length altogether. So when we label this, across from the 30, remember, is our x, so I'm going to leave that as my x. The medium side is our x square root 3, and our hypotenuse is the 2x. So notice we can set those equal to solve for our purple x. When I set 8 equal to 2x, I get x equals 4. So that means all of my purple x's are going to be a 4. So we know now that the apothem is this 4 square root 3. For the perimeter, we know one of the side lengths will be 8 because this little piece is 4. So the side length is 8, but we have 6 sides. So when we multiply it, that gives us a 48 for the perimeter. And now we can take both of those and put it into our formula. So we get 1/2 times 4 square root 3 times the perimeter of 48. Once we multiply that, we get 166.277, and that would be units squared since they didn't give us any units. Now, where we can use the area of our regular polygons is going to be when we get down here for number 4 and number 5. So we have a triangle that's built into our circle, and we want to find just the area of the shaded piece. So if you ever have a shaded region you need to find the area of, you need to take the area of the whole entire shape, so that would be our circle, and we're going to subtract out the area of our white shapes. That would be the area of our triangle, and it's a regular triangle since we have all 3 sides that are congruent. With this next one, we would take the area of the whole entire circle and subtract out the area of our hexagon. Just like I said up above, it's better if you set up your paper the way that you're going to need it. So we know the area of a circle is pi r squared. We know the area of a triangle, but this is a regular triangle, so we're going to use 1/2 a times capital P, and same with the area of our hexagon, we're going to use a times our capital P. So we just have to find out what those different lengths are. Like in the circle up here in this one, we can see the radius of the circle is 10. So the first part of it we already have, and we can start plugging in. This would give us 100 pi for that length. And I'm going to leave it as 100 pi most of the time. Now, for the area of our triangle, we need to do what we did up above, and we need to draw out that triangle a little larger. And the triangle that I'm doing is the triangle that's, if I split it up into my equal triangles, this is only the shaded, my little pink one, that's the one I'm drawing. So I know that the radius is 10. Then I divide it straight down the center, and I don't know what those are, but I can find out what the degree is. So I can take 360 divided by my 3 triangles that are created, and I get 120 degrees for this full angle. That means each of those individually would only be 60, and with our 90 we already have, that would give us the remaining angles down below are 60. So what we can do, we're going to use sine, cosine, tangent again just so we can practice that. So we've got our 30 across from that then would be my opposite side. This would be my adjacent, and then I have my hypotenuse. And if I want to label this, I'm going to put this as x and this is y down here. So if I want to find the opposite, I would need to use my hypotenuse and my opposites. That would be sine, and that is opposite over hypotenuse. So I'm going to do sine of my angle, which is 30, equals opposite was my x, over my hypotenuse of 10. So when we cross multiply, I'm just going to multiply those two together. So 10 times sine of 30, and that gives me that x equals 5. So I know my little apothem is going to be 5 because that's the height right there. Now for the perimeter, I need to find out what my y is over here. So if we do adjacent with hypotenuse, that would be cosine. So I'd have cosine of my angle equals adjacent over the hypotenuse. So now when we cross multiply, I'm multiplying my 10 times the cosine of 30. This gives me 8.66. Now remember, that's only part of it, so I need to find the whole length of it, so I need to double that. That would give me that one side is 17.321. So we're going to take 17.321. I need to multiply that by the three sides in my triangle, and then I can subtract those out. When we multiply all this together for the area of a hexagon, we get 129.904, and the area of our circle is still 100 pi. So now I want you to tell me, what does your area of the shaded region equal? Once you subtract it, you should have gotten 184.255, and this would be units squared as well. Now moving on to number 5, we already discussed that the area of a circle is our pi r squared. We need to take that and subtract out this white space, which is the area of the hexagon. And we have seen this before where we have the 7 is the radius. So when we draw our triangle, that is the length of both of these pieces. We know a hexagon now. If we divide our 360 by our 6, we get our 60 degrees. That's up here, which means that if we go straight down, both of those become 30 up there at the top, and then we have 60 down here. And remember, with our 30, 60, 90 triangles, we have 6, our x square root 3, and then our 2x. So we set our 2x equal to the 7, we get that our blue x's all equal 3.5. So that means this is 3.5, this is going to be 3.5 square root 3, and this will also be 3.5, so that means all the way across is 7. So now we've got our pieces for the a and our capital P. So the little a is our 3.5 square root 3. Our perimeter then, we need to take the 7 of this outside piece, and there are 6 of them, so times 6, that would be really 42. So we've got 1/2 times 3.5 square root 3, and then times 42. Going back to our area of a circle, and we have pi r squared. The radius of our circle is the 7 that we were already given, so that's 49 pi minus this other number. So 49 pi gives us 153.938. The other number gives us 127.306. So when we subtract that, I've got 26.632, and that would be units squared since we are dealing with area. Now remember, for the shaded region, you always have to subtract out the part that you do not want. And since we want the gray part, we have to find the whole thing and subtract out the parts we don't want, which is the white area.